Good morning, students. Today I will discuss the working principle of four-stroke IC engine. Myself, Dr. Debasis Adhikary, Associate Professor, Mechanical Engineering Department, Haldia Institute of Technology, West Bengal, India. Today I will explain here the working principle of IC engine. First of all, we have to know what is IC engine. IC means internal combustion engine. Internal combustion. Here in the engine, the combustion of the fuel or ignition of the fuel will be happen within a chamber, and also work done will be done into the same chamber. So the chemical energy by burning or by combustion of the fuel will be transformed into the mechanical work done within the same chamber. That means the combustion is taking place within the same chamber, so it is called internal combustion engine. Now here are the use various vehicles, petrol engine, diesel engine, gasoline means various gas engines, compressed natural gas engines, all those will be included are included within the IC engine. Now there are another type of engine that is called EC, called external combustion engine. Here there's IC engine and EC engine. So before going to the IC engine, we have to know what is external combustion engine. Now in the external combustion engine, the combustion will be taking place within a combustion chamber which is outside of the engine. For example, in steam thermal power plant, the steam is generated within the boiler. So boiler is the combustion chamber, but work done is done within the turbine. So turbine is another part, that is engine, heat engine, and the combustion chamber boiler is another part. So after combustion of the fuel, that is uh, combustion of the fuel, for example, coal-fired power plant, by burning the coal, steam is produced within the uh, mm, uh, boiler, and the steam will go to the with high pressure and temperature will go to the turbine, and the high pressure and temperature steam will be expanded within the another chamber called the turbine. There the high pressure will be transformed into the work done and pressure will be decreased. For external combustion engine, say this is the boiler, and coal is fired here, so the water within the boiler will be transformed into the steam, and steam will go to the another engine, another heat engine, another part. This is called the steam turbine, and turbine will rotate. This work done, mechanical work done, will be transformed into the electrical power, electrical energy through the generator. This is the generator, and this is the turbine. And the exhausted steam, wet steam, will go to the condenser. Here in the condenser, the steam will be transformed into the water, will be condensed into the water. Again, the pump will pump the water into the boiler. So into the boiler. Here this is the heat engine and this is the combustion chamber. So with respect to the heat engine, the combustion chamber is external part. So that's why it is called external combustion engine. Now in case of internal combustion engine, most of the cases, for example, petrol engine or diesel engine or gas engine, there will be one cylinder, inlet valve, this is inlet port, outlet port, and this is called outlet valve or exhaust valve. Here this is called inlet valve, and here will be the piston. Through the inlet valve, air fuel mixture, means petrol plus air, will be mixed within the carburetor. External of the of this cylinder will go into the chamber through this port, and inlet valve will be open. So here will be the charge. Excuse me. And here will be the, in case of petrol engine, here will be the spark plug. Sparking will be there. After this compression, compressed gases will be increased into the high pressure and temperature. Then suddenly sparking will be done, so that the spark will ignite the fuel and combustion will be there within this chamber. Due to this combustion, then the pressure will be increased abruptly within few seconds. Then the high pressure will be applied on this piston, and piston will be placed in the backward. So piston movement will be backward. That means the high pressure will be transformed into the linear motion. So the force into the displacement, that means will be the work done. So here in this chamber, the combustion along with the work done will be happen within the same chamber. Combustion will be the within the chamber where work is done. That's why it is called internal combustion engine. Now we are concentrating on the fully on the internal combustion engine. So in case of internal combustion engine, first of all we have to know what are the types of internal combustion engine. First is spark ignition engine, that is used in case of gas or petrol. So this is called spark ignition engine, because the ignition temperature or self ignition temperature of the petrol is very low with respect to the diesel. So sparking can be done in case of petrol, but in case of diesel, sparking will not be sufficient for igniting the diesel, only the sparking. So high pressure and high temperature is the main factor in case of diesel. Now in the spark ignition engine, so called the, in case of petrol engine or diesel engine, where those petrol engine or diesel engine are used in case of spark ignition engine. For example, two-wheeler, four-wheeler, Spark ignition engine means petrol engines are used. But in case of heavy vehicles like bus, truck, then diesel is used. In case of train also, diesel is used. Not only that, some four-wheelers, in some four-wheelers, diesel also used. And in case of IC petrol engine, that is in spark ignition engine, the thermodynamic cycle is Otto cycle. Otto cycle. This is here is the Otto cycle. In case of Otto cycle is here presented in PV and TS diagram. In PV diagram, see here the cycle 1, 2, 3, 4, 2, 1, the cycle. Here the 1 to 2 is the compression, and 2 to 3 compression. 1 to 2 is the compression. In it is happened in isentropic process, and 2 to 3, that is the end of compression. Ignition will be there, and the charge will be ignited. So heat energy will be added to the cycle. That is represented by here 2, 3, and 3 to 4. That is expansion. It is happening in expansion stroke, or this is called also power stroke. So 3 to 4, this is isentropic expansion, and 4 to 1, constant volume exhaust of the gases from the cylinder, and also it is represented in the TS diagram. You have to know the area, cycle area within PV diagram. It is representing the work done, but the area under the TS diagram representing the heat transfer. Now I am going to the diesel engine, another type of engine, that is compression ignition engine. Already I have told you that in case of diesel, the only spark is not sufficient. So in case of diesel engine, sparking is avoided. So a big compression ratio is taken, so that after at the end of compression stroke, the temperature will be very high with respect to the petrol, so that the diesel, in case of diesel engine, only air is compressed. At the end of compression, the air temperature will be very high, and then diesel will be sprayed within the cylinder by the nozzle, so that only the air temperature will be sufficient to ignite the diesel. So after igniting the diesel, the pressure will be very increased, and that pressure will push the piston, so the work done will be happened. And in case of diesel cycle, in case of the thermodynamic cycle named here the diesel cycle. In case of diesel cycle, similarly the Otto cycle, compression ratio 1 to 2, that is happened in isentropic process. But the difference is that 2 to 3, the ignition process, the heat addition process here is happening in constant pressure process. But in case of petrol engine, that was, or spark ignition engine, that was in constant volume process. But in case of diesel engine, it is happening in constant pressure process. Then 3 to 4, isentropic expansion or power stroke, and 4 to 1, constant volume exhaust or exit of the gases, burned gases from the cylinder to the atmosphere. This is also represented in the TS diagram. Now I am going to in details the thermodynamic force stroke. It is written here the force stroke. Why it is written here the force stroke? Because the here, the previous slide, the suction, compression, expansion, and exhaust, there are mainly four processes in case of thermodynamic cycle, that is suction of the air petrol mixture or only air in case of CI engine, compression ignition engine, that is in diesel engine, only air will be sucked within the cylinder. This is happened in one stroke. When the piston will move from the, this is called top dead center and this is called bottom dead center. From the top dead center to the bottom dead center, then the fresh charge mixture of air petrol or in case of diesel engine only air will be go into the chamber and the inlet valve will be opened in this time. So this is the first stroke. Piston will move from, here it is written 0 but here I am writing here 1 dash, so say this is 1 dash. So the piston here moving here, I think this figure will be very easy to understand here. This is PV diagram along with the cylinder displacement. Cylinder, first piston will be here in the top dead center. Why it is called top dead center? In case of the engine will be vertical, then this center will be above the level with respect to the this level, that is bottom dead center. So the piston will be, for example, piston will move from the top position to the bottom position, top position to the bottom position. So top position is called the top dead center, bottom position is called the bottom dead center. So this is the top dead center because the piston will move up to that limit and it will move back then up to that limit. So this is called bottom dead center and this is called top dead center. When the piston will be here, then only clearance, this is called clearance volume. The length is called C and this is the displacement of the piston called stroke length L. So the volume within this clearance length, that is VC, is equal to, sometimes it is called V1, that is pi d. D is the bore diameter, cylinder internal diameter d. So pi d square by 4, that is area, into length will be C. So it will be the volume, clearance volume. Because the piston will not move after that line, that is after top dead center, and the piston will, when move backward, then the total displacement of the piston will be from here to here. This is stroke length. Then what will be the volume? The stroke volume is equal to the cross sectional area pi d square by 4 into L. Stroke length then will be the stroke volume. But here it is written V1. It will be written V1. It is VC. VC, right there, VC. So if it is generally denoted by V1 with respect to that point V1, so V1 will be the clearance volume plus the stroke length volume. So Vs, clearance stroke volume will be pi d square 4 into L, and the total volume here V1 will be this clearance volume plus the stroke volume. So Vc plus Vs. And when piston will move from here to here, from top dead center to the bottom dead center, then on the PV diagram we can draw the line 1 dash to 1, 1 dash to 1, that is called suction stroke. So in one stroke, one thermodynamic cycle is happening here, that is suction stroke. So the total with the force I am discussing later, with the total 4 strokes of the cylinder, the total thermodynamic cycle, that is in Otto cycle or diesel cycle, will be completed. Again another cycle will be started. That's why it is called 4 stroke. Now, so there are some few points to be noted here. During the intake of the charges, inlet valve will be closed, exhaust valve, inlet valve will be opened, exhaust valve will be closed, and piston will be moved from top dead center to the piston will be moved from top dead center to the bottom dead center. Next, at the end of after 1 dash to 1 suction stroke, then 1 to 2 here 1 to 2 1 to 2 compression stroke will be there. Then the piston will move from bottom dead center to the top dead center. First, in the intake, piston will move from bottom dead center to top dead center to the bottom dead center, and next bottom dead center to the top dead center. Then the total volume, that is V1. So V1 and this is V1 dash. So total volume V1 will be compressed to V1 dash, called the clearance volume. As the V1 volume of charges will be compressed, what will happen? The pressure and temperature will be very high. And at the end of compression stroke 1 to 2, the sparking will be there. After sparking, suddenly within very say for example very few seconds means fraction of second, say 1 by 100 second or 1 by 1000 second, the combustion will be of the petrol will be there. Then what will happen? The piston will not get the time to move backward. Suddenly the pressure will be very high, 2 to 3. Within 1 by 1000 second, the pressure will be very high. Suddenly the pressure will be increased from 2 to 3. And also heat energy, with respect to the heat energy transforming the pressure energy, and this pressure mechanically pushes the piston to backward. So in the second stroke, that is compression stroke, this is 1 to 2. Here is the first stroke, stroke 1. This is the stroke 2. Sorry. So this is the stroke 1. This is the stroke 2. In stroke 2, 1 to 2 and 2 to 3 both will be happening. Now next the stroke 3. In stroke 3, expansion will be there. Next, expansion 3 to 4, another stroke, and 4 to 1 will be the exhaust valve will be opened at the end of the expansion stroke, and suddenly with very high pressure the sum of the smoke will be go outside, but there will be no stroke. At the end of expansion stroke, just slightly before the expansion stroke, exhaust valve will be opened and the gases will try to go out from the will start the go out from the cylinder. So this is called the constant volume exhaust. And after that, so this will be the stroke 3. In the stroke 3, 3 to 4 and 4 to 1 will be happen. So in the thermodynamics again, in the stroke 3, that is in expansion stroke and also called power stroke, and at the end of power stroke, what will happen? The exhaust valve will be open, inlet valve will be closed, the gases will be go out from the cylinder to the atmosphere. The gases will go out. This will start before the end of the expansion stroke, but some of the gases will go outside. After that, what will happen? The pressure will be decreased to the more or less atmospheric pressure. Then what will happen? Then the remaining gases will not go outside. They will stay within the cylinder. In that time, the piston will move from right hand side to the left hand side, that is from the bottom dead center to the top dead center. Then what will happen? The remaining gases which are staying within the cylinder, they will be they will go outside by force, by giving the force by the piston. So piston forcefully, the gases forced to go outside of the cylinder. So the next step is the next step will be sorry exhaust stroke. Yeah, exhaust stroke 1 to 1 dash. Next step will be the 1 to 1 dash. So here the main processes, that is suction, compression and ignition, expansion and exhaust. The four processes happening in the four stroke of the pistons. Top dead center to the bottom dead center, suction, compression, expansion, exhaust. Again, suction, compression, expansion, exhaust. Those processes happening in the four stroke of the piston. That's why it is called four stroke. Previously was the two stroke engine. Nowadays the two stroke engine has been already obsoleted because there are so many reasons. In two stroke the air pollution will be very high, thermal efficiency will be very low. That's why it is obsoleted for getting the better environment. Now the question is here, I mean highlighting the difference between the Otto cycle and diesel cycle. Otto cycle is applied in the spark ignition engine for petrol and gas, and the diesel engine in diesel cycle. Diesel cycle in diesel engine. So my question is, why ignition of a gasoline takes place at constant volume? Why ignition of a diesel takes place at constant pressure? 1, 2, 3, 4. 1, 2, 3, 4. This cycle is Otto cycle. Here the heat addition or ignition or heat addition taking place is 2 to 3. That is in constant volume process, because this is volume, this is pressure. And in case of diesel engine, the cycle will not go 2 to 3, 2 to 3 dashed. So in case of diesel engine, that area or that part 2, 3, 3 dashed, that part will be rejected in case of diesel engine. In case of diesel engine, so heat will be added in constant pressure. Here heat will be added in constant volume. Why? The reason is that in case of petrol, the ignition temperature is very low. So what will happen at the end of piston, end of compression stroke, sparking will be there. Suddenly the charge will be ignited. Charge will be ignited within fraction of seconds, so that the piston will get the time to move backward, and suddenly the pressure will be increased from 2 to 3. So in case by sparking, the petrol sparking, the time will not get by the piston to move backward. Within very small time, the heat will be added here and pressure will be increased. But in case of diesel, piston is always moving in the running condition, is moving. If there will be some misfiring, then also piston will move backward, because there will be the motion already, it is gain the motion. So after in case of diesel, diesel will be sprayed here by the nozzle at the end of stroke. Diesel will be sprayed here by the nozzle. Air is in high temperature, compressed air with very high temperature. About it will vary from 600 to 900, 500 to 900 degrees centigrade. Within in this temperature, diesel will started igniting in various points, but not the whole diesel. Again, the diesel around this point they will start burn. Again, the diesel around the layer they will start burning. So the burning of the whole diesel within this clearance volume will take some time. But within, say for example, say 1 second will be required for burning whole the diesel. Then what will happen? The piston will not wait for burning of the whole charge. Piston will automatically move from here to here. Then what will happen? Pressure is increasing somewhere, but piston is moving here. So what will happen? The volume also increases, total volume. Then pressure will decrease here. Again, pressure will increase, but piston will move backward here. Then again, total volume is increasing. Then what will happen? Pressure will decrease in this way. So we are taking here more or less constant pressure. After that, when piston will start to move back into this level, then what will happen? For example, the the combustion of the whole diesel will be completed. Then the diesel will start to push the piston backward. That means then we will get the work done. So work done will happen from 3 dash to 4 dash in case of diesel engine. So with if the compression ratio, what is the compression ratio? Compression ratio, say RC is equal to the ratio of this total volume divided by this volume. This volume is called V1 and here VC. This volume is VC and from this end total volume is V1 here to here VC. So compression ratio will be say VC is say V2. So compression ratio will be V1 by V2. When the stroke length will be very high, then compression ratio will be very high. When the stroke length will be low, then compression ratio will be low. So for the same compression ratio or for the same stroke length, the area under the diesel cycle is lower than the petrol cycle. Because in case of petrol or auto cycle, not petrol cycle, we will call here the auto cycle or used in petrol or gas engine, the 1, 2, 3, 4, the area is more than the 1, 2, 3 4. This area is more in case of auto cycle, that is 2, 3, 3 dash. So with respect to the same stroke length, the work done, already I have told you that the area under the PV diagram representing the work done. So in case of diesel engine for the same stroke length, the work done, this is our objective for getting the work done. So work done 1, 2, 3 4 will be less than the auto cycle. So this is the main difference between the 4-stroke compression ignition engine or spark ignition engine. Then here the expansion and stroke, last stroke, that is exhaust stroke 1 to 1 dash is explained here. Already I have explained you previously. Again, just highlight, there are 4 stroke: suction, compression, power and exhaust. 0 to 1 here is the suction, compression 1 to 2, 2 to 3. In compression stroke, 2 processes. In compression stroke, 2 processes in the cycle is happening, 1 to 2, 2 to 3. And expansion or power stroke, that is 3 to 4 and 4 to 1. and at the exhaust stroke 1 to 0. Now the key difference between the Otto cycle and diesel cycle. I am highlighting here the key difference here between the Otto cycle and diesel cycle. First, type of fuel. In Otto cycle, gasoline, that is petrol or gas, is used. In case of diesel cycle, diesel is used. And ignition, in Otto cycle, spark ignition, that is spark plug is used, because here the air fuel means air and petrol which is mixed within the carburetor outside of the cylinder and transformed into the cylinder. And in case of diesel cycle, only air is sucking into the suction stroke into the cylinder. So only air is compressed. After that, the diesel is sprayed by the nozzle, and the ignition of the diesel will happen due to the high temperature of the air. That's why in case of diesel engine, high compression ratio means a high stroke length is used with respect to the Otto cycle, means petrol cycle or gas cycle or gas engine. Next is combustion or ignition process. Already I have told you. In case of Otto cycle, constant volume combustion process, and in case of diesel cycle, constant pressure combustion process. Next is compression ratio. Already I have told you that in case of petrol engine, compression ratio is low, and in case of diesel engine, the compression ratio is higher than the diesel engine, because in case of diesel engine, at the end of compression stroke, high temperature is required so that the diesel can ignite, because the self ignition temperature of the diesel is higher than the petrol or gas. So what is the correct data for Otto cycle? The compression ratio varies from 8:1 to 12:1, where the while the diesel cycle engine it is varying from 15:1 to 23:1, means air and fuel, means here if the 1 kg petrol is used, then 11 with respect to the volume, 1 meter cube or with respect to the we say weight, 1 kg of petrol is used, then 8 kg of air will be required. 1 meter cube of petrol will be used, then 8 meter cube of air will be required. So this is air and this is petrol. If 8 is the air, then 1 is the petrol. If 15 is the air, then 1 is the diesel. So in case of diesel engine, more volume of air will be required with respect to the Otto cycle. Now, air fuel mixture. In Otto cycle, petrol and air which are mixed outside of the cylinder, that is within the carburetor. But in case of diesel cycle, only air is sucked. Already I have told you. And the diesel is sprayed separately at the end of compression stroke by the nozzle. In the next air fuel ratio. Now go to the data. Air fuel ratio. In case of Otto cycle, the stoichiometric air fuel ratio means, what is the stoichiometric? Now complete combustion occurs, then what will be the ratio now with respect to the chemical equation or chemical reaction? Then what is the ratio? That is called stoichiometric ratio. That is 14.7:1 in case of Otto cycle. But in case of diesel cycle, 18:1 to 25:1. It will vary. Next, thermal efficiency. Thermal efficiency, already I have told you that. Thermal efficiency we can compare with respect to the two conditions. First is due to the lower compression ratio, the Otto cycle thermal efficiency of Otto cycle less than diesel cycle. In case of Otto cycle, compression ratio is taken lower than this. What is the compression ratio? 8:1, which will be less than the 15:1. That's why here thermal efficiency in Otto cycle less than diesel cycle. But if we consider the 8:1 in case of diesel also, then That means if the compression ratio will be same, then the efficiency of Otto cycle will be greater than the diesel cycle. Already I have explained in the previous slide. Next, application. You know Otto cycle, that is gas engine or petrol engine used in four-wheeler or two-wheeler, and diesel cycle, commercial vehicles, bus, truck, etc., etc., train. Then temperature and pressure at the end of compression. Already I have told you that in the Otto cycle, temperature and pressure at the end of a compression will be lower than the diesel cycle. And what is the value? The temperature from 200 degrees centigrade to 500 degrees centigrade in case of petrol or Otto cycle. But in case of diesel, see here 500 degrees centigrade to 800 degrees centigrade. And the pressure in case of Otto cycle, that is 8 bar to 15 bar. But in case of diesel cycle, pressure 30 bar to 40 bar, very high pressure. That's why, as there is a high pressure, then high pressure will be applied on the piston. Obviously, we get the more power or more work done from the diesel engine. And speed, Otto cycle is called the higher speed engine, and diesel cycle is lower speed engine. In Otto cycle, speed of the flywheel on the shaft will be very high. It will be ranging from 1500 rpm to the 6000 rpm. But in case of diesel, 1000 to 4000 rpm. So diesel engine is rpm in diesel engine lower than the Otto cycle, means in petrol engine or gas engine. And noise and vibration, in Otto cycle, noise will be less than the diesel cycle. Okay, I think students, you understand the four strokes IC engine, working principle of four stroke IC engine. So just sum up. IC engine means internal combustion engine. That means the combustion of the fuel will be happen within the cylinder, as well as the work done will be within the same combustion chamber. That is, the combustion of the fuel and work done will be happen within the same chamber, called here the cylinder. But in case of external combustion chamber, combustion engine, EC engine, the combustion of the fuel will be happen outside of the engine. And why four stroke? It is written there are mainly four processes happen by the four stroke of the piston. First is, for example, top dead center to the bottom dead center, top dead center to the bottom dead center. That is suction. Suction means the sucking of the air petrol mixture or diesel. Or only air. That is called suction. Then compression of the charge, maybe only air or maybe air petrol mixture. Then combustion will be at the end of compression stroke. So it is not considering any stroke. And then expansion stroke, and the expansion means power stroke and the exhaust stroke in this four stroke. Thank you, students.